Yeah, today I want to go over another way to show numbers. This time, within the print, we're going to use a string method to display the numbers how we want them without actually going in and changing the values. So let's make a number. We're going to make a floating point number. Just kind of a, I'm going to type in just a few things here. And now we have a floating point number. And if we want to, as we discussed before, if we wanted to change things, we could use the round function and on it and some of the other functions. But another way to do this is to keep the number how it is, but do some extra stuff in the formatting in the print. And we'll put a string here with these curly braces. And I'm going to tell Python that whatever I give this, these curly braces and the colon, that I want to format it as a floating point with two decimals. The dot 2f would be floating point as 2. This may look strange to you at first, but it can be useful. And then go format, and we're going to put num1. Okay. So what I'm trying to do here is I have this floating point number, but I'm not using the round either in the function or beforehand to do any formatting. I'm going to do it right here with this format, and I'm telling it dot, so decimal 2, so 2 places for a floating point. Let's run this, see what happens. Oh, it's gonna ask us to before we do anything to save it, so we would find a name that we don't already have, and we run it, and that's what it did. So you guys could probably guess that if we were to want to see all 4 or 3, we could basically copy that. Let's go for three places here, and let's rerun that. And we have 3 here. And this is just another way to do that, but you could do more with this, which is kind of neat, because you may be saying that oh yeah, that's like the round but much more difficult to use, but we could do other things. Now what we're gonna do is we're gonna add commas. So I'm gonna copy one of these down here, and this is pretty cool, because a lot of times, especially if you're doing some sort of report involving accounting or some sort of financial numbers, people really want to see commas in there after like in there to help people count all the zeros better, and it's a pretty standard request. So what we're going to do is we're going to add that. So we'd go back to the 2. So right here we do the same thing, but right after the colon, if we put a comma, that's going to tell Python that this format wants to see commas. So let's run this again. And now you can see the same thing. It's basically the same as up here, but we have we put commas in there. I mean, it's commas if you're using Excel. They have a special Excel format for you to do that. Pretty standard that people want to see those commas in counting. So when you get at the bigger numbers, if you have those commas, you could figure out, your eyes can easily look and go, oh gosh, that's 1,000, or that's over 1,000,000, and commas help. So this is a wonderful way to do that. Even though that it seems a lot easier to do around for the ones up here. But when you get into stuff like commas, I mean, the format's going to do that for you, and is going to do that for you nicely. Another place that's kind of handy to use these formats is for percentages. So let's make a number 2, and we're not going to write a whole bunch of code, but we're just going to assign a percentage value. Let's say, if you had a larger program beforehand, to get that 0.321, you had a big calculation, and it looked at a few things, and you ended up with a percentage expressed as 0.7321, and you want to nicely show it as a percent. So we're going to copy this down here, and let's change. We're going number 2, and in here we're going to put that, and we're going to run it. Okay. So you see, express the value as a percentage, and even put the percent sign, which is nice. I mean, you could just multiply it by 100 and get a percentage, but this throws in the percent sign too. So it is indeed useful, as you'd expect. If we were to do something like this, where we say we want another point up another decimal place. So let's run this, and you can see that it goes a little further into the decimal places. Now let's look at some of the things we could do with integers. So we're going to do a num3, and we're just going to make up an integer. That seems like a good integer to me. We're going to copy some of this so we don't have to retype in everything. And we're going to change that to num3. And dealing with integer, integers are just D. And I'm going to put a comma D in there. And as you may recall, the comma should put commas in there. So we should just get an integer that looks something like 7, 321. So let's run this. And that's what we got. So it lets you work with floats, integers, percentages, and last but not least, let's look at one of our number. Let's look at num3. So let's change num3 into scientific notation. For whatever reason, you may want to do this. So let's go and in the code for scientific notations E, and we're going to have 1E that we should be saying that we should be using I guess we have an issue here. Somehow in the process here I knocked out one of the curly braces. Okay. Invalid format specifier. Okay, we still have the issue. Let's slowly look at that. Oh, let's get that comma out of there. And what I need is a decimal place. Okay. So when in scientific notation, it did it with one decimal place. I want to talk about another module which we can use with numbers. In this particular module, we can use with currencies. It's called the locale module, and we can import it like this. And I'm going to put an alias to it. We just call it LC. Now the first thing we're going to have to do is basically set our locale, and we're going to do that with just at first we start with the US. So when we do start looking at currencies, it will be US currencies. Okay. We set our location, and let's test it out with a print. So we're going to use a function in it called currency when we do use our printing, and I'm just gonna, instead of assigning a variable and setting up numbers, I'm just gonna throw a number directly in here to make it more I guess quick. And let's see if we want grouping. Is it big enough to be grouped? Nope, but we will set that there because people do like numbers grouped, especially if you're making a accounting type program. So let's run that, and let's name it something. There we go. And what you see is a US dollar sign. So this fine and dandy when we're talking US dollars. But let's say we weren't talking dollars. You have an international program, and you were talking British pounds. So I'm going to change that location to UK, and we're going to basically keep the rest of it the same. So let's rerun it. And now you can see we're talking pounds. If you had to do some actual conversion, that'd be a whole nother story. We'd have to figure out the difference between a pound and a dollar and do conversion. This is more on the format end. And what this the locale module gives you is a variety of formats and functions you can use for formatting. So let's try another one. It's kind of a last one we're going to do here, and we're just going to copy down what we have, and let's say we're working with a client in China, so we're going to run it. And there we go. Handy on if you're doing maybe have some sort of web program that's international. Although in most cases, I think most people using Python for data analytics may never use this module, but it's good to know about, especially if you're doing you're working on something international. So far we talked about integers and float, but there's another type that we have to include to get it. It's called decimal, and think of it as a more accurate float. And people that are really concerned with things being rounded just to perfection, just right how they want it, often import this other type into Python. So what I'm going to do is I'm going to say from decimal, and we're going to import, and we're going to import a new type called decimal. And what this is going to do is from the decimal module, it's going to import the actual type of decimal, and show you here in a little bit what I'm talking about as type. Let's say we had some totals, something called total 1, and we're going to make that decimal, which is what I just imported above. And we're going to have 100.005. And to kind of run along with this, let's just make a float. We call that tote2, and we're just going to assign it the same thing. So if we were to print the actual type, so I'm going to type TOT1, and let's copy that code down here and modify it a little bit, and let's change that to 2. So what I'm going to do here is that we imported in decimal as a new type. It's going to be new decimal object we can use, and we're assigning it here. So tote1 is assigned this new type of decimal that we just imported in, and we're going to use it to do a variety of things with. And the other one is the standard float. Will get assigned to it, and we're going to verify that. So we're going to run it, and it's going to ask us to save a program name. So let's give it one. Okay, so we can see the when we made a float, that the float is a class of float, so it's a float object. But the other one, the new one, it says decimal, and that's the module, and then decimal is what we assign the type. So we have a new type, and a lot of people use this type to try to get more accurate and to try to avoid some of the rounding errors that you may get by pulling it in and having more control over how things are rounded, more accuracy in the actual calculations. It's definitely one way to do it. A lot of people never pull this in. They use floats. They're just a little more careful with roundings. So we're going to print these out now, and let's use a round function, and we can go tote 1-2, so that's going to round it, and let's copy that down to use the tote 2. Okay, so now we're going to do a print with a round of both of these, and we get basically the same thing. We have a little difference in here it's not displaying the other 0 that we get here, but it's basically the same thing. And if you look here, we have 0.005, and sometimes you might want it to round up, but it doesn't always do that with by default with the 5. You think, well, 5 goes up. Well, not when there's another implicit 0 behind there. But if we were to change things here, so now we're 0.0051 for these, and let's run the same program again. Okay, so this flipped it over, but in a lot of cases you might feel, well, you don't want it to really behave that way. And one of the nice things about the decimals and the decimal object that we pulled in here, we could change that. There's things we could apply to make it round differently, and we're going to look at one of those right now. So we're going to change it back to here, and we're going to go back to decimal, and we're going to pull something else in. This time we're going to end up or pull in round half up, and there's a variety of these that you can use, and all out there in the Python documentation. And we're going to make a total 3, and we're going to go total 1, which was the decimal, and we're going to apply this type of rounding to it with the quantize function. Actually, it's the quantize method. And let's put that there, comma, and round half up, and then we're going to print it. So what we did was first we inputted this in here. There's a round half up, there's a round half down, and there's a round half even, which is the default. All dealing with this critical thing of what do you do if you're at the total midway point, and which is 5 in a base 10 number system that we have. So we're using the round half up. So we set our new number here. We have the tote 1, which isn't a float, but one of these decimals that we imported. We're using this method. We're telling it we want it to round like this decimal that we have here, and we want to use this method, round half up, and then we're going to print it. We can run it, and we can see that it hit that magic point, the midway point, and in this case it went up. It was a 5. It's going to go up, matter what's matter if it's a totally with a 0, and there's a implicit 0 that is there after the 5. You don't put a 1 or another 0 or 2. It's just kind of implied. And even without a 1 to push it up, it's going to round up on that 5. We can make it round down if we want to. That one's probably not used as much. So decimal, the decimal, importing from the decimal is something that can be used to help get some of the rounding errors out. But like I said, you can do the same with regular floats by it's just occasionally with multiple roundings and multiplications you can get into some issues. And even above just the things you may encounter with roundings, a float is really a kind of an approximation of a number. The decimals are more accurate, so that's another thing to bear in mind. And that may make you want to, especially spend a little extra time to actually create a decimal object instead of a float object.